Okay, so if you're taking AP Physics, you know there's one problem that seems to show up everywhere, and it trips up almost everyone. Yep, I'm talking about the normal force on a ramp. Today we're going to bust the biggest myth about it so you can totally master this thing for your exam. Let's get right into it. So, look over on the left. You've got a box on flat ground. Simple, right? You've probably solved this problem 1,000 times. But then, we just tilt this surface a little bit, and suddenly all those simple rules you thought you knew, they just don't seem to work anymore. So what's really going on with the forces here when we add an incline? All right, before we can break the rule, we gotta understand the rule. And it all boils down to this one definition, the normal force. Now, the key word on this entire slide, the one you really need to tattoo on your brain, is perpendicular. The normal force always, and I mean always, pushes perpendicular to the surface it's coming from. That's its only job.
On flat ground, that perpendicular rule leads to a really simple, really comfortable equation. You've got gravity, mg, pulling straight down, and the surface pushes straight up to support it. The forces are perfectly balanced out, so the normal force, N, is exactly equal to the object's weight, mg. This is that simple rule we all learn first. It feels safe.
But here it is. This is the trap. This is the question that really separates the students who get it from those who are just guessing. We take that same exact box, we put it on a ramp. Does our simple little rule, N equals mg, still hold up? Your gut might say yeah, but as you know, physics can be pretty counterintuitive. And here is the absolute key to understanding why that old rule breaks. The normal force isn't some fixed number. It's a response force. Think of it like a trampoline. It only pushes back as hard as you're pushing on it. It only responds to the force being shoved directly into it. If you get this one idea, the whole rest of the problem just clicks into place.
So here's the problem in a nutshell. Gravity doesn't change. It's always going to pull straight down towards the center of the planet. But the normal force, remember its job description? It has to be perpendicular to the ramp. And now, just look at them. Those two forces are no longer pointing in opposite directions. They're at an angle to each other. And that, right there, is why our old friend N equals mg is officially broken.
So, how in the world do we solve this? Well, the trick, it's kind of clever. We just tilt our perspective. Instead of thinking in terms of up and down, we're going to start thinking in terms of parallel and perpendicular to the ramp. As soon as we do that, we can see that the single gravity vector, mg, can actually be split into two separate pieces, or components. One piece is trying to pull the box down along the ramp, and the other piece is pushing the box straight into the ramp. And since our normal force is a response force, which piece do you think it cares about? Yep, only the part pushing directly into it.
And breaking down that vector leads us straight to this beautiful solution, the real formula. The normal force on any ramp is mg times the cosine of the angle of that ramp. That cosine of theta bit, that's just the mathematical tool that lets us perfectly isolate the size of that perpendicular component of gravity we were just talking about. This is the formula you need to know. This table just makes it all so clear. Let's plug in some numbers and see what happens. When the angle is 0 degrees, so flat ground, the cosine is 1. That means N is just mg. Hey, look at that. Our old rule was just a special case of this new, better formula all along. But watch, as the ramp gets steeper, say 30 degrees, then 60, that cosine value gets smaller and smaller, and so does the normal force. The surface is supporting less and less of the object's weight. Until, at 90 degrees, a vertical wall, the cosine is 0 and the normal force is 0. The surface isn't supporting it at all. The object is just in free fall. Okay, you might want to screenshot this or just write it down. This right here is your master key for the exam. Number 1, normal force is always perpendicular to the surface. Say it with me. Number 2, on a ramp, you have to break gravity into components. No way around it. 3, N equals mg cos theta is the tool that finds the force pushing into that ramp. And finally, please, please, please don't fall for the trap. N equals mg is a special case, not the rule. Now you know why, and now you know how to avoid that mistake. So we've totally nailed the perpendicular story. That's the normal force, that's the mg cos theta. But wait a minute. Remember how gravity had two components? We've basically ignored that other one this whole time. So what does that parallel component, the one that's pulling the box down the ramp, what does it do? Well, that, my friends, is the force that makes things accelerate, and it's the force that friction has to fight against. But that's a story for another time.